Welcome to radar system course. Today we continue here that the radar block diagram. So in a radar block diagram, if you see that it has a separate transmitter and a receiver, that both the transmitter and receivers are separated by only a duplexer. So we have the duplexer here. So that duplexer will separate out that communication between a transmitter and receiver. So if you see here, the role of a duplexer means it will be active for transmission purpose. Okay, whenever we transmit a pulse there, and when we are receiving the pulse, the transmitter, that particular portion will be off here. Okay, so then we will just go ahead. Okay, so we will continue here. Okay, so now if you see that this duplexer role, just it used for separating the transmitter and receiver. Now come to the topic that is about a transmitter part. So in a transmitter, we supposed to use a power amplifier because that signal when we are transmitting, that is about a high pulse, or what we can say here, that is about a high uh, high power. Okay, so transmitted power of that particular signal is to be high. That's why we supposed to use a power amplifier to send the pulse. Okay, so to send that particular signal to the object there. So here we use a power amplifier, but we supposed to consider that that pulse or that waveform is to be generated, or that signal is to be generated from the waveform generator here. So mostly if you consider that the people are using a Klystron tube amplifier for amplification of the signal, or people are using a oscillator here, that is a magnetron based oscillator, so it will generate a pulses there. So that when we are using a pulse radar there, or a pulse transmitting, so in that case we supposed to consider that a, a magnetron as a pulse radar there. Okay, so now we consider here for a transmitter purpose, so what type of a signal we supposed to be transmitting here. So here we say that a pulse radar, so in that case we supposed to use a magnetron, so that will be used as a oscillator there. Okay, so then we supposed to consider that a power amplifier also, even if supposed to be your device is sufficient to generate that much of a power. For example, a magnetron is there. Okay, so it is used to generate the pulse there, and we supposed to require a high power, then and then we go for the power amplifier. If supposed to be that output of that magnetron is sufficient, so in that case we supposed to not use any power amplifier here. Okay, but generally in a radar we use a power amplifier because to detect the range or detect the object, that is for a long distance object. Okay, which present object is present in a long distance there. So that's why we supposed to use a long distance or a power amplifier for the detecting the object whichever the present is. So generally it is in a nautical miles, that object is present in a nautical miles, and that is to be uh, detected by the air radar there. Next, we consider here signal produced by the waveform generator. Generally we supposed to consider that waveform generator means what? It is about a low power signal. So if it is a magnetron there, so then it is having the high power magnetron we can use. So if it is a low power generator, so low power pulse or low power waveform, and that is to be amplified. So that is to amplify through the a power amplifier there. So in the case of a device, which devices we are using, either we can go for a traveling wave tube amplifier, or we can use a Klystron based amplifier there. Okay, two cavity Klystron amplifier, or we can go for the solid state devices. So in that case we supposed to use a solid state device, a power amplifier. Okay, so this way we can generate a single signal, or we can say generate a single pulse, and then how that pulse is to be transmitted. So generally, if you see that a radar signal is about what, it is about a pulse. Okay, so means in that case, whenever we are sending one particular pulse, in that case that pulse is to be on here, and then pulse is to be off. So that's why we are supposed to use a modulator to on off the pulse, and then that particular signal is to be transmitted there. Okay, so this way, so we can say that when we transmit a pulse, okay, so in that case transmitter is to be on. Okay, in that particular on period, when we are receiving the pulse, the transmitter is to be off and receiver is to be on. So so the transition takes place in between that a transmitter and receiver. It's different here. Okay, so we can consider that what will be the a pulse durations we have, and a on period and off period of a transmitter here. So according to that, we will consider that a transmitter pulse. Okay, so this way we supposed to use that a transition for the that what will be the on pulse here duration, and what will be the off pulse duration, so that we can transmit a signal and we will receive the echo signal within a particular period of a time there. Okay, so that is about it. Already we have discussed that pulse repetition frequency. The same thing applicable here for your signal here. Now, once we say that a high power signal is generated, then we supposed to use a switch. Switch is nothing but a duplexer. So in duplexer is a device. So it consists of a solid state component circulator over there, so that when we are transmitting a signal, so it will just transmit a signal in a given direction. When we are receiving the signal, so that received signal will not be affected. That received signal will not reach to the power amplifier, or whatever the echo signal we are receiving from the antenna, so that will not reach to the a your transmitter here, transmitter section. So this one is about a complete a transmitter section. We supposed to consider this particular part, or this particular portion is nothing but a transmitter here, and this below portion is nothing but a receiver here. Now this transmitter and receiver both are separated. Means at a transmitter, when that high power signal is transmitted, so in that case the same signal should not go to the receiver. Otherwise, what will happen? Receiver will damage. Whenever we are receiving the echo signal, that echo signal should not reach to the transmitter there. Okay, so that's why echo signal is directly goes to the receiver there. Okay, so this way we supposed to consider that a, device or a circulator here, so that or a transmit receive switch at the time of transmitting. Okay, so only this will forward it. At the time of receiving, this will be directed to the receiver here. So that is about a duplexer device. Then we have an antenna. So in that case, we supposed to use a antenna, so that will provide a narrow beam. Okay, so there are the various kinds of antenna we can use. Okay, so that we will get that a narrow beam. Okay, so the role of a narrow beam means what? We will get a high gain, or we supposed to say that your signal is to be transmitted for the long range or a long distance there. So that's why we consider that a narrow beam antenna. But when we are using a high power, okay, high power signal to transmit it, that antenna is to be transmitting that high gain output, okay, high gain output here. So in that case, that device or that a antenna, that is to be rotating always in a 360 degree, because antenna is scanning. Because when we are sending a pulse, that pulse is to be reflected back from the object, means echo signal will reach to the receiver. So that's why this antenna is to be steerable one. So we need to rotate the antenna 360 degree in azimuth, okay, in ground plane here, okay, or we supposed to use a different phase to be provided so that instead of rotating, okay, phase array antenna, if supposed to be we are using, so rotation is not necessary. So that beam will be diverted in any other direction. So in that case, we can receive the echo signal. Okay, so this way. So mostly people are using a phase array antenna or a parabolic dish antenna, and that parabolic antenna is to be a steerable one. Steerable means what? It is to be rotating in a 360 degree there. So now we say that a a high power signal is transmitted. So what will be the size of that particular antenna? That is depending upon the what is our requirement. Requirement is based on that at what operating frequency this signal is transmitting there. So based on that, a diameter of that particular parabolic dish will be changes, and we will get a narrow beam there. Okay, so that is about your antenna. Then at when we are receiving the echo signal from the device, okay, then a rule of a duplexer comes in. So duplexer will not allow to transmit that echo signal to the transmitter there. It will transmit that echo signal at a receiver. Okay, so this is about receiver. So some devices or some radar, it doesn't have a low noise amplifier there. They have directly the mixer. Some they have the low noise amplifier. Why? Because if we use a low noise RF amplifier here, so it will take a time to read the signal or to read the object. So that's why most of the cases that low noise amplifiers are not available there because a radar mostly used in a military applications. So in a military applications, even if there is a noisy signal present, that noisy signal is to be detected by the radar. Okay. So then noisy signal means what? Any signal in a given region that is to be detected by the device. So that's why this low noise block is not there in a military radar. But if you consider that the other radars, suppose in air traffic control radar to be used, so in that case, they have the low noise RF amplifier block. Now, the low noise RF amplifier block is used before this a mixer stage. So it will remove if supposed to be noisy signal, so that will be removed by this whatever the region there, and only if it is a sensitive signal or a low signal is there, so that will be amplified by this a device there. Okay, that is about your role of this low noise amplifier. Okay, now next stage is about a mixer here. Okay, so generally we can suppose to say that a receiver type. What will be the receiver type? Generally we say that a receiver is used in a radar is about a super heterodyne receiver. So in a super heterodyne receiver, so there may be a mixer stage, and then mixer stage will convert whatever the RF signal to the whatever the required for this intermediate frequency amplifier, IF amplifier. So local oscillator, the role of a local oscillator. So generally we are expecting that whatever the RF signal, so that is to be extracted from the this particular that echo signal is there. So echo signal consists of a carrier, and that carrier is to be extracted from this particular block. Okay, so in that case we are expecting a particular signal, and this signal is having some particular bandwidth. So IF amplifier is used to just get the signal within a particular band of frequency. Only that particular band of a frequency signal is to be passed through it. For example, I am saying that if my pulse width is about a 1 microsecond. In that case, bandwidth required is about a 1 mega. So this one IF will work for the 1 megahertz there. Okay, so this one, a block, IF block, then a detector block, and then amplifier. These are the three blocks that are useful for the generating the envelope, or we can say that this one is about the envelope detector block. Okay, these three blocks are supposed to be considered as the envelope detector block. Now the role of this video amplifier and a detector is different. Detector, this is just like we have a pulse, that carrier is to be removed, only whichever the pulse we are sending, that is to be detected here. So the role of a detector, or we can consider that a demodulator there. Okay. So what what will be there in the match filter? Okay, why? Okay. Generally we consider that a IF amplifier, and that IF amplifier is supposed to provide a that particular band of a signal, and the role of the filter is supposed to check whether it is a that IF amplifier is designed for a particular band of a frequency or not. Okay, if supposed to be there is some particular noise available there, okay, noise is there, or if it is supposed to be unwanted signal, okay, not related to whatever the expected signal, so that is to be removed by this particular match filter. Okay, suppose we have this particular block is not there, so unwanted signal will be removed by using this filters there. Okay, so this one. So maximum generally the role of a match filter is to detect the whichever the echo signal is there, and remove that unwanted signal. Okay, remove whatever the unwanted signal. Okay, so that is about the role of this particular match filter there. But in the case of a signal, we say that a pulse is to be transmitting. Okay, so in that case, what will be the shape of the pulse? For example, we are saying that a pulse is about a rectangular shape. So in that case, a, match filter is used to detect that particular shape of the pulse, or that particular pulse width of the given particular duration, because this one is about the echo is to be received. So according to that, we can consider that a receiver bandwidth is depending upon that what will be the pulse we are transmitting there. Then we can say that there is a detector. So we can say that a combination of a IF amplifier, a detector, and a video amplifier, that particular block, these three particular blocks will be act as a envelope detector. And this particular mixer, okay, if supposed to be we are not using a low noise amplifier, and we are just supposed to be use a mixer there. So in that case, what happened here? This particular mixer, we supposed to use a match filter. Okay, so means each and every blocks are dependent. So what type of a radar we have, for what purpose we are using designing this particular radar. So according to that, few blocks will be changed there, or few more blocks to be added here. So this generalized radar block diagram. Okay, if you see that we have a transmitter section, we have the receiver section, and these are nothing but a generalized block diagram of a radar. But in the case of a military applications, we say that this block is not there, only mixer is there. Okay. So in that case, what happen here? So any noisy signal will be there. So noisy signal can be detected by the radar there. So means your radar can be worked at any noisy environment. Okay. So then forget about that. This particular noise is present. So that's why if it is detected, that noise signal is detected by the radar. So then it is called as a false alarm rate. Means we are detecting the noise. Okay. So likewise, so that's why for any device we supposed to consider that how much will be the level of the signal is to be detected by the device. Okay, echo signal. Whenever echo signal will reach to the device, then there is some particular threshold is to be required. Okay, so if we have the low noise, this particular portion is there, not there, and directly it goes to here. Okay, so it is removing. Okay, so noise and all. Okay, so in that case, this particular portion is. But this low noise RF amplifier, which it is used to detect the very weak signal also. Okay, so generally we say that what is the minimum detectable signal? Okay, if this block is there, so it will use to detect that whatever the minimum signal. Okay, minimum detectable signal. So this one. Okay, so likewise we consider that a device that is to be useful for the minimum detection, and what will be the what will be the requirement for the device. Okay, so, so we consider that a demodulator portion detect that particular signal, and we have the video amplifier. Okay, so video amplifier is just useful for the provide a amplification for a given particular signal so that it can be displayed on the display devices. Okay, so that's why is sufficient level of the signal is to be there. So that's why it is supposed to be display the signal on the display devices. And then what will be the level of the signal? So for any device or any radar, we supposed to know that what will be the minimum signal level received by the device. Then we supposed to consider that for a given particular output signal, this much will be the detectable signal level. So that's why we supposed to assign one particular threshold value or if one particular threshold, so that below that threshold the signal is to not to be displayed. Okay, or you can say that above that particular threshold signal is present, or below that threshold a signal is not present. Means whenever we are receiving any echo signal, if that echo signal is more than that threshold value, then we can say that signal is detected, that object is detected. If that echo signal is less than that particular threshold value, then we can say that object is not detected. Okay, so in that case we supposed to tune the device in such a way that that device will useful for detecting the echo signal for the given range, and then we supposed to find out that what is the threshold factor. Okay, and that threshold factor will use to identify that whether that object is present or not. If supposed to be any noisy signal is more than that particular threshold, so in that case that is nothing but a false alarm. Okay, that is about a means your radar detecting some object, but there is no object. Why? Because of that noisy signal is greater than that a threshold level. So why this happen? Okay, because in a military application, so supposed to be sometimes what happen, a false signal is to be sent for a given particular range, or a jamming signal is to be sent. So in that case, that false alarm is detected by the a device. Okay, so we need to know about that. What is a false alarm rate of a device? Okay, so it is depending upon that what will be the threshold we have selected and what will be the noise level we have selected, consider there to detecting the given particular objective. Now, apart from this, okay, apart from this, whatever the signal we are receiving, that signal is to be processed by the signal processor also. Okay, so another devices, another components are present in the radar. Okay, so then we have the output. That output is to be displayed on the display devices. In old days or old radars, there were a CRT. Nowadays there is a pulse position indicator. Okay, and nowadays there are a lot of devices, display devices are there to detect the object from the whatever the location of the object there. and that locations or that their range, everything is to be displayed on the display panel or a display devices there. Okay, so these are the exactly or whatever the block diagram. Okay, like, generalized block diagram. So, but in the case of a receiver, so there are the lot of devices can be there, lot of blocks to be there. There may be a signal processor. Okay, okay, whatever the video amplifier we are having, there are the video amplifier, or there may be a detector circuit. There may be a display devices, amplifiers, and all. Okay, so like that. So there are a lot of combinations of components are there in this particular case. There. Okay, so these are about the radar block diagram. So now next we continue here a discussion regarding the what are the different particular frequency range is to be used by the radar there. And in the most cases, we supposed to consider that the radar useful for the military applications. So in that case, that are radar useful for the different aeronautic applications, okay, air traffic controls and all. So in that case, the operating frequency of the device will be different. So mostly we say that radar is operate it with a various operating frequencies. Again, we can use the same radar, okay, for with a different polarization. So as you know that there are the various types of a polarization, and we can use a different polarization technique to identify or to detect the object present in a given particular region there. Okay, so that is about what we can say that a radar and their radar block diagram. And we have mentioned earlier whatever the frequencies we have used. Okay, radar frequency. And that radar frequencies are nothing but what we say that it is about, mostly we say that it is about a micro frequency range. Okay, 300 megas to 300 gigas. So even if we consider that some radars are operating from the 100 megahertz also. Okay, that case 100 megahertz to 100 gigahertz. Okay, that is about the range. So we can say that a radar can be operating from the very high frequency band, VHF band, okay, or up to the 300 gigahertz. So VHF band, if you see that, what is the VHF band range? VHF band range is about a 30 to 300 megahertz. Okay, that is about the VHF band. Then UHF, okay, ultra high frequency, that is about a 300 megahertz to 1 gigahertz. 300 megahertz to 1 gigahertz. And then L band. Okay, L band is about a 1 gigahertz to 2 gigahertz. Okay, then L, then S. Okay, then C. Okay, L, S, C. After that X. This one is about a 2 gigahertz to 4 gigahertz. Then a 4 gigahertz to 8 gigahertz. Then a 8 gigahertz to 12 gigahertz. Okay, so now these are about the various bands there. Okay, so you're supposed to know that what will be the band of a frequency. Then KU band, K band, KA band. In that case, 8, sorry, we supposed to consider that 12 to 18 gigahertz. Then we have the 18 to 27 gigahertz. Okay, and then K, 27 to 40 gigahertz. And then after that, we have the band, various bands are there. So then we can say that a V band, okay, it is about a 40 to 75 gigahertz, and a W band is about a 75 to 110 gigahertz. Then a millimeter here, millimeter is about what? 110 to 300 gigahertz. Now these are about the frequencies of a radar there. Okay, so various frequencies of a radar that are used. So mostly, if you consider that these are the band of frequencies are used by this radar up to 40 gigahertz nowadays. Okay, so they are about the band of frequencies people are using. Okay, so military applications and all people are using this particular band of a frequency. Then what are the applications of a radar? So already we have seen few earlier application at the time of introduction. Okay, so we supposed to again consider that what are the radar applications we will consider again here. So there are the various applications of the radar there. So then that applications of a radar we can consider that we say that a military application. Okay, so already we have discussed that a radar application earlier. So this one is useful for the a defense system. Okay, military radar. So in this case, we supposed to find out that whether there is any missile there, incoming missile, or detecting the missile or missiles operations there, or detect that weapon there. Okay, or in weapon control system, these are radars are used there. Okay, so mostly for a surveillance region, okay, or a surveillance purpose. So these radars are used, okay, for a military application. So it is useful for the target detection, recognition of the target, then attracting the target there. Okay, so missile systems. Okay, that is about a uh, nowadays Russia and Israel we have taken the missile system. That is about missile system that S-400 something from the Russia, and I forgot the name of this. Okay, missile Israel missile system that we have taken. Indian people have taken. Okay, Indian government have taken. So now that are useful for the detecting the weapon or detect tracking, controlling the radar, controlling the missiles, everything that are useful for the military application. Then another examples that is we can say that application a remote sensing one. That remote sensing generally the term if you see that it just observing, okay, it just observing or monitoring the weather there, okay, or weather predictions or a planetary observation, or we can say that what is the region, okay, or we can say the flood monitoring and all. So that for that particular purpose the radar can be used. So these are about the remote sensing application. So now for each and every band, okay, if you say that these are the various applications, so frequency used for each and every applications will be a different, okay, because that particular object is to be reflect that particular signal. So that's why if supposed to we say that a snow is there, in that case, so which particular signal will be reflecting by the snow. So that is particular frequency is to be used there for the given application. Then air traffic control, okay, ATC here. So in that case, so whatever the aeroplanes and all, okay, so whichever the or we can say that airport, in the airport that controlling the traffic of the aeroplane, everything is to be controlled by this air traffic control there. Okay, so this one used at the airport there. So mostly the radars are there, and that radar is scanning. Scanning means what? It is 360-degree rotating. Military radar again, it is a 360-degree rotating. This remote sensing radar fixed at a given particular position there. Okay, so these are about the scanning radars are used. They are rotating 360 degrees there. Then we can use a law enforcement here and highway safety. Okay, law enforcement and highway safety means what? So it is useful for measuring the speed of the vehicles. Okay, so generally what happen? So any for particular highway or particular road, there are some speed limit mentioned. So in that case, so to observe the what is the speed, okay, of the vehicle. So for that purpose, this that radar is used to measure the speed of the vehicles and all. So these are just like producing a safety warning across the road there. Okay, so we can consider that a device that is useful for the measuring the speed and all. Okay. Next is about we can consider that a air safety and a navigation there. So navigation part is about a to find out that a object is present in a given particular region, and that to provide the path or provide the direction for the given particular in a given region. So air safety, okay, air traffic control to find out that particular object is coming. Okay, so likewise that particular object. This one is about in a space. Okay, so this one is about a navigation part is there. So mostly, if supposed to be there is a weather, so in that case for a given particular weather, so need to talk about the safety of the devices or safety of the aeroplanes or safety of the military aircraft and all. So in that case, so air safety and navigation. So these are the applications of the radar there. Okay. So to identify that if supposed to be there is a high, okay, heavy rain and all, so in that case, so it is unable to detect that particular region. So navigation is difficult. So that's why we supposed to use measure the what conditions are available. So according to that, that particular object or the aeroplanes or whatever the aircrafts are there, so that is to be diverted at a given particular position, okay, or a direction. Then a ship safety. So generally, even in air safety, again the collision of that particular aircraft is not to be takes place. That particular thing is to be taken place because we need to find out the particular what will be the height. Okay, so similarly in a ship here again the same thing is to be taken place. So if there will be a nearby ship is present, so that is to be identified by the ship. Okay, so that's why no collision will be takes place. Okay, even in marine, okay, we can say that marine applications mostly that radars are used. Okay, so we need to consider that. So what will be the position of the that particular ship? Okay, that can be identified. So that is about a ship safety. So again, then a space there, so space vehicles and all, so that radars are used. Okay, so means we know that we need to land a or landing the object on the moon or okay Mars somewhere. So in that case, a radar is to be used. So in that case, it is to be used to detect the place or detect the object, tracking the objects and all. Okay, so there are the various applications. Even nowadays, if you see that there are the uh, we can say that people are using mostly in vehicles that radar devices. Okay, autonomous vehicles. Okay, so small radars are used. So various applications are there for the radar there. Okay, so and we just conclude here what will be the various topics that we have learned today. That is about the radar block diagram that we have learned. Okay, and what will be the minimum detectable signal that we have learned earlier. Now we will see next. So what will be the noise? Okay, in a given particular signal, and what will be the modify radar equation. Okay, so with this we stop here. So thank you all of you.